So lab number 4 from chapter 9 and 10 is an opportunity for you to see kind of a real-life example of when this hypothesis testing and confidence intervals would maybe come into play. There's a business in this case, and they're doing a data analysis to be able to report to their customers about the amount of time that it takes to get an oil changed. So let's look here at this scenario. So suppose you're the manager of a Speedy Oil Change, which claims that it will change the oil in customer's car in less than 30 minutes on average. Okay, so you're advertising, hey, on average it takes less than 30 minutes to get your oil changed at our Speedy Oil Change service. So come here. That's what they're advertising. Further, suppose that several complaints have been filed from customers stating that their oil change took longer than 30 minutes. So in other words, you're advertising that the average time is less than 30 minutes, but there are individual customers saying, hey, it took more than 30 minutes. It was 35 minutes or whatever. So, something's wrong here. Now, I would point out immediately there's a mismatch, okay? You're claiming that it's 30 minutes on average. That means if you add up all the time that people spend and divide by how many there are, the average is under 30 minutes. You're not necessarily claiming that every individual car is under 30 minutes. So I would point that out right away. And I think that that's a common misconception when people hear things about an average. You're not claiming as the business that every single car will be under 30 minutes. You're claiming the average amount of time is under 30. So there could still be some cars that are more than 30 minutes, and you're still meeting your claim here. So I would point that out right away. And maybe this advertising campaign needs to maybe, look at that a little bit and see if they could word that a little differently, because it does sometimes cause some confusion with people's interpretations. But let's go ahead and assume that, analyze it from what's written on the paper here instead of perhaps rewording the campaign. So upper level management at Speedy Oil Change says, hey, you're the manager. We want you to investigate these complaints. So you say, okay, fine, I'll investigate. I'm going to randomly audit 36 oil changes performed by Speedy Oil Change and record the time each customer waited for their oil change. So you randomly pick 36 cars that come into the business, time how long it takes for them to get their oil change completed. And that data is recorded here. I have entered that data already in my calculator. Stat, edit, and there's my data right there. I put it in L1. Okay. Make sure that you do that before you carry on with the video here. Okay. So here's our data. Then they say in the questions below, you will test if the mean is less than 30 minutes at a significance level of 0.01. Okay. So they say to test it. That means hypothesis test. At a significance level of 0.01. So significance level is our alpha. We're using alpha equals 0.01. All right, they want us to start out with any hypothesis test. We have to write our null and alternative hypothesis. Make sure we label them. Remember, your null is labeled HO, and your alternative is labeled H1. All right, this problem is about the average wait time for an oil change. Average is another word for mean. So our symbol, we're going to be using the mu for population mean, the average time for all the cars at the oil change place. That's our whole population. So we are making some claims about the mean. Now, remember our null hypothesis, we always use the equal to. And the number that we're going to use here is 30 because we are making a claim. Remember, your claim is the H1. We're making a claim about how the mean oil change time compares to 30. So since we're going to use 30 in our claim, we have to use 30 in our null hypothesis. So mu equals 30. And then our alternative, our claim, it says we are testing that the mean is less than 30. So mu is less than 30. Now, I would point out that that matches the claim. Remember, the advertise says, hey, the average is less than 30. That's what you're claiming. So that is going to be your alternative hypothesis, that the mu is less than 30. All right, calculate the test statistic and the p-value. All right, remember on your formula chart, if we are doing confidence, there's confidence intervals. Here's our test statistic and p-value from a hypothesis test. Test statistic and p-value, when you're working with means, you're going to pick the t-test feature in your calculator. So you have your data in your L1, and we're going to go to Stat. We're going to do a test, and we're going to pick T-test, option 2 here. We're going to pick T-test. We're doing a hypothesis test about means. Our data, we have the actual data. We don't just necessarily have the statistics yet, the mean and standard deviation, all that good stuff, but we have the actual data. And so then my mu naught here, the number that I used in my mu and my null and alternative hypothesis is 30. So I'll type that in right there as 30. It needs to know where your data is. Mine's in L1, so I want L1 right there. I push second 1. Frequency, I'm going to put 1. In other words, I just listed each of my 36 cars one time. So I'll leave frequency as 1. And then we have to pick whichever symbol, not equal to, less than, or greater than, whichever symbol we use in our alternative hypothesis. Our alternative hypothesis says that the mu is less than 30. So I'm going to pick the less than symbol. This is saying mu is less than the number I put in mu naught, which was 30. Okay? And then I'm going to calculate. Notice they want both the test statistic and the p-value. Test statistic in this case is t for the student t distribution because we're working with means. So my test statistic is this negative 3-point number. They specifically say 4 decimals. So negative 3.5126. And then they want the p-value. Okay, so my p-value, labeled as p. Temptation is to write 6.222. No. Remember, p-value is for probability. Probability always has to be between 0 and 1. It cannot be 6 point something. But look at this value. See that E at the end? That means this number is in scientific notation. So really, it's saying 6.222 times 10 to the negative 4. So when I convert that to a decimal, and my decimal moves 4 places to the left, it'll go past the 6, and then 3 more times. So I'll have 0.0006 when I round to 4 decimal places. Okay, remember we always have to be careful of that. We sometimes see that, 6 or whatever, and we have to realize, oh wait, that's a p-value, it's probability. Check and see if you've got a scientific notation conversion that you need to take care of. All right, number 3, using the p-value calculated in number 2, explain why you would or would not reject the null hypothesis. Remember, if the p-value is lower than alpha, so I'm going to compare my p-value to alpha, 0.0006. Alpha was 0.01. P is lower than alpha. P is less than alpha. And when P is low, we must reject the HO. We must reject the null hypothesis. So write a statement about that you are going to reject the null hypothesis because your p-value is less than alpha. I'll let you write that sentence yourself. And then on number 4, notice on number 3 they said don't write your conclusion. You're just saying whether or not you're going to reject. On number 4, we're actually going to write our conclusion about whether or not the company fulfilled the promise to change the customer's oil in less than 30 minutes on average. Well, if you reject the null, that means you are supporting the alternative. You have evidence, statistically significant evidence to support the claim. And the claim was that, yes, it would be on average less than 30 minutes. So you need to write some sort of sentence there saying, yeah, we are supporting the claim that it's going to take less than 30 minutes on average. Remember that on average does not mean every individual car is less than 30 minutes. It's the average. If you look at your data here, some people were more than 30 minutes. Some people took 42 minutes, 41 minutes. There were others that were less. Here's a 19. Here's an 11. So some are more and some are less. We're just saying that the average is under that 30 minutes. And we have statistically significant evidence to support that. Okay. Now, you present the evidence to your bosses at the upper level management, a speedy oil change, and they say, well, that's great, but people are still complaining. Okay, you got some people that are still can't handle it, and they're mad that they had to wait 42 minutes or whatever. So you say, okay, let me do some more analysis here, and let me answer the question of how much less than 30 minutes our average oil change wait time is. Okay, so if I can tell customers, hey, on average we're under 30 minutes, you can expect to maybe wait a couple minutes less than 30 or 10 minutes less than 30 minutes or whatever. So you decide to analyze it that way. And you're going to construct a confidence interval, a 98% confidence interval for the mean number of minutes it takes the oil change on average to be done. So this time we're still doing means, but this time we're doing a confidence interval, so we'll pick the feature T interval in our calculator. So stat, I'm going to arrow over to test. I'm going to pick T interval, option 8. And I got to tell it, hey, I've got data. I don't have the stats. I just have the data. My data is in L1. Each number was recorded one time. And my confidence level is 0.98 because they told me 98% confident. And I'm going to type it in. Remember, what comes out will be your confidence interval. They've given us quite a few decimals here. They specifically tell us for our answer to round to 1 decimal place. So I'm going to say 21.4 if we round to 1 decimal place, up to 28.4 if I'm rounding to 1 decimal place here. That's my confidence interval. Okay? Now remember how we interpret that. That means that we are 98% confident that the average amount of time that customers have to wait for their oil change is between 21.4 and 28.4 minutes. Okay, that would be the sentence that we could write out for how long it takes oil changes to occur. Using this interval up here, calculate the point estimate and the margin for error. Remember, point estimate is the number in the middle. Now, we need to find the middle number. What's halfway between 21.4 and 28.4? Certainly you could average these together. You could take 21.4, 28.4, add them together, divide by 2, and that would give you the point estimate in the middle. Your calculator also just tells you the point estimate. Okay, remember, since this is about means, X bar is the average or the middle. So 24.9 would be the halfway mark. Okay, and certainly you could average them together and verify that. Now, margin of error. So on a number line here, we're saying that 21.4 is the low end for how long the average time would be. 28.4 would be the high end. And 24.9 would be in the middle, the exact mean of the amount of time people have to wait. Margin of error is this distance, how far it is from the low end to the middle or from the middle to the high end. So the margin of error for both of these values should be the same. So I could do 24.9 minus 21.4, and that's 3.5. Or I could do 28.4 minus the 24.9. Either way, I get 3.5 because the distance from the low end to the middle or from the middle to the high end should be the same. So our margin of error is 3.5 minutes. Okay? And then what they ask us to do in number 7 is say, hey, based on that confidence interval that you got, how much less than 30 minutes is our average oil change time? So, we're saying, hey, on average it takes we are 98% confident that the true average wait time is between 21.4 and 28.4 minutes. How much under 30 minutes is that? So in other words, if we're on the low end at 21.4, how much lower than 30 minutes is that? Or if we're at 28.4, how much lower than 30 minutes is that? So I'm going to do 30 minus 21.4, and I'm going to do 30 minus 28.4, and those two values are going to represent how many minutes under the 30 it takes. So those two values will be there and there. And you'll be able to say, okay, your oil change is likely to be, 3 to 7 minutes less than 30, or whatever those subtractions come out to be. Okay? All right, so hopefully that will help you with your last lab.